Hey, welcome to Trixaw. Today we'll be discussing related rates. In order to start learning about related rates, you have to know about implicit differentiation. So if you haven't already watched it, please go ahead and watch my video on implicit differentiation that I've already made. So what is related rates about? Well, it's about finding the rate of change of a quantity using other quantities whose rate of change is already known. For example, it could involve questions in which two quantities are simultaneously changing, and you might know one of them, and using some information you have to find the rate of change of a chosen quantity. Let's take a look at what a related rates problem might look like. So we're given the equation 2x squared minus y is equal to 16, and we're also given that dy dt is equal to 4. So we're asked to find what is dx dt when x is equal to 4. So in this problem, dt means with respect to time. So an x and y are both quantities that are changing with respect to time. But we know what dy dt is, but we need to find out what dx dt is at a certain value of x. The first step to doing these kind of questions is to take the given equation, which is 2x squared minus y is equal to 16, and derive both sides of the equation with respect to time. So let's go ahead and do that. First, we can start with the left side of the equation. dt 2x squared minus y is equal to dt 16. So how can we simplify that? So let's find the derivative of 2x squared with respect to time. It's going to be 4x times dx dt. What about negative y? It's going to be negative dy dt. And ddt of 16 is just 0. Let's move on to our next step now. We can solve the equation for dx dt in terms of everything else. So our next step could be 4x times dx dt is equal to dy dt. And then our final step would be dx dt is equal to dy dt over 4x. And we're given dy dt, which is 4. And we're also given the value of x that we want, which is x equals 4. So 4 times 4 is 16. So our final answer is 1/4. So in summary, given the equation that 2x squared minus y is equal to 16, and we also know that dy dt is equal to 4, we concluded that when x equals 4, dx dt is equal to 1/4. And this uses a lot of implicit differentiation, so it's important to know. Let's work through a word problem now. A balloon is being inflated and its volume is increasing at a rate of 10 cubic feet per minute. The balloon is perfectly spherical. How fast is the radius of the balloon increasing when the radius is 5 feet? So this problem is going to use a lot of the same principles as our last problem. First, let's start out with our equation. The equation for the volume of a sphere is volume V is equal to 4/3 pi r cubed, r being the radius. And because we're dealing with time, let's go ahead and derive this equation with respect to time and see what happens. So deriving both sides of the equation, we're going to get dv dt, the change of volume with respect to time, is equal to 4 pi r squared times dr dt, which is the change of rate of radius with respect to time. Okay, so what can we go ahead and do now? So the question is asking, how fast is the radius of the balloon increasing when the radius is 5 feet? So we need to find dr dt because that is the rate of change of the radius of the balloon. So let's go ahead and solve this equation for dr dt. And that should be pretty simple. All we need to do is move everything else other than dr dt from the right side of the equation to the left side of the equation, which is going to leave us with dr dt is equal to dv dt over 4 pi r squared. And now we should be able to plug things in. dv dt is 10 because the question states that the volume of the balloon is increasing at a rate of 10 cubic feet per minute. So dv dt is 10. Now what about the denominator? It's going to be 4 pi times r squared. And what is r? R is 5. So r squared is going to be 25. So what do we get? We end up with 10 over 100 pi. So our final answer is 1 over 10 pi. But it's very important to remember units. So what's the question asking? How fast is the radius of the balloon increasing? So we already know the question previously uses feet because when describing how fast the volume increases, it says 10 cubic feet per minute. So how fast is the radius of the balloon increasing? It's 1 over 10 pi feet per minute. And that's it. That's a related rates word problem. Thank you so much for watching. I hope you enjoyed this video. If you have any questions or any other calculus or physics concepts you'd like me to discuss, just leave a comment down below. Thank you for watching. As always, please subscribe.